Hello again, and welcome once again to the Near Futurist podcast. My name is Guy Clapperton. And if you're a regular listener, you'll be well aware of what comes first. Here's a quick advert for my media training service at Clapperton Media Training. Do you or your clients want to sound as confident, clear, and fluent in media interviews as the people in this podcast? Of course you do. My team and I can help. Drop my assistant Lindsay, that's lindsay@clapperton.co.uk, a note, and she'll set us a time for an initial chat. Or go to the website at clapperton.co.uk, two P's, to find out more. Now, back to the podcast. And that's enough of that. Now, this week we're taking a look at networking, the technology that allows one computer to talk to another, or many, across the wires. Ages ago, this expanded to ISDN, then satellite, fibre, and wireless more recently, and there may be another development, photonics-based networking. More on that in a second. My guest's expertise includes high-speed networking, SDN, cloud and edge computing, AI, and data management. He is the head of NTT's Research and Development of Innovative Optical and Wireless Network, which abbreviates to IOWN, IOWN, as the IOWN Technology Director. He is also serving as the chair of the Technology Working Group at IOWN Global Forum, which is what we're here to talk about. His name is Dr. Masahisa Kawashima. Dr. Kawashima, welcome.
Thank you. Thank you very much for having me.
You're more than welcome. This sounds intriguing, but for someone hearing about this for the first time, what is photonics-based networking in simple English?
It's a network using light. Today, we use packet network, and packet network uses electronic processing. On the other hand, with IOWN's network, we use light-based switching instead of electronic-based switching. So that's the main difference.
Okay, now we already have light-based networks in terms of fiber optics. How does this compare to fiber optic?
Okay, so fiber optics is basically the method of data transmission from one place to another. But when we say light-based switching, it's more about how you exchange data inside your building. For example, speaking in analogy with logistics system, of course, we may use truck or airplane from one logistics station to another logistics station. But the question is how we exchange the packets inside the logistics station. And in today's network, basically, we use an electronic-based packet switching system. But with IOWN, in our network, basically, we use a light-based switching system. That's the difference.
So what's the problem with the internet as it is, or with networking as it is at the moment, that you're trying to fix? Because they do appear to work.
So basically, today's internet is designed to send information to human. For example, internet is used for human-to-human conversation, or information services from web server to users' smartphones. So basically, the information is recognized by human anyway, and because it takes a second for human to recognize information, the latencies are in the order of seconds does not matter. But in today, we have many AI applications. So we have to support AI to AI communication or robot to robot communication. In order to such a communication, basically the communication latency should be in the order of milliseconds. And in order to achieve that, we need a new network technology, such as light-based switching.
So, what sort of applications is this going to support? What benefits will we actually see?
One of the important application is, of course, AI. For example, we may have some AI agents that talks to many AI in the cloud. That is one application. And another use case is actually not AI, but for example, even for today's IT systems, such as transaction systems used by financial service institutes, they want the communications that can achieve much shorter latency. And so another application is the transaction systems of the financial service industry.
I suppose the speed of these transactions is such that we wouldn't notice if there are only one or two of them, but when there are thousands of them, the benefits do start to accrue. Uh, what surprised you most when you started getting involved in this space? I mean, I'm old enough to remember when dial-up internet seemed incredible. So, have there been any surprises when you've been developing the technology?
Well, one of the surprising is, for example, many devices getting more efficient. Basically, the efficiency is doubling almost every 2 years. So, for example, 10 years ago, we couldn't imagine that we could have 10 gigabits per sec internet line. But today, that's possible. So I'm very surprised at the speed of innovation, how fast the device becomes efficient, more efficient.
The other thing is, of course, 10 years ago, we couldn't have imagined needing a 10 gigabyte per second, or
Yes, right, right.
we might not have imagined what the applications would be. If we could look, say, 5 years into the future, this is a futurist podcast after all, what difference do you think people will see on networks? What difference will people see on their devices that are not possible now? Can you think of any likely use cases?
Well, likely use cases, for example, today we have internet. The internet through internet, users can communicate with any service in the world. But 5 years later, probably user may not need PC in his or her home because the computing devices in data centers can function as if they were in users' homes. So basically, today we have PCs and servers in a user's environment, and these PCs servers are connected to data centers. But in future, basically because the user's environment are connected to data centers with a light speed network, then probably a user's devices would not need would not need computing capabilities. So that's the future. That's one of the scenarios that I can imagine.
That's interesting because I've read a number of times that data centers use an awful lot of power. So, in terms of the ecological pressures, that might militate against throwing away all the computers that we've already got and relying on something that's going to consume an awful lot of power on another site. And there's also the issue of data sovereignty as well. We don't.
Yes,
I
yes.
don't necessarily know where all my music is stored. I probably should do, but I use Spotify. I believe it's in Europe, but I'm not all that certain. I'm only thinking about it out loud now. Is this going to bring in those sort of managerial, those sort of compliance
Yes,
issues
of course.
alongside? Yeah.
Yes, yes, of course. First of all, speaking about not having computing resources in your home, it's good for users living in urban environment because in urban environment, basically, there are a lot of other things that consume energy. So we would like to reduce the energy consumption. So let's move our computers to data centers in rural areas. That could be a solution to reduce the carbon emission of urban areas. And speaking about the data sovereignty, even if we use computers in rural data centers, basically today's technologies will allow you to lock your data, even if your data is stored in rural data centers. So data sovereignty can be solved with the recent security technologies.
I get that. I understand that. But if my data were, say, to be located in a rural data center that happens to be in the US, because I've gone for AWS or something like that, Amazon Web Services. If it happened to be in just elsewhere, then it will surely be subject to the American data laws rather than the British data laws. Now, those are fairly closely aligned, but you could find some interesting culture clashes going on, couldn't you?
Yes, that's an interesting question, and we can solve it. It's a kind of operational issue, and of course, that's where the community is working. So we, as a community, can define the how the infrastructure should be operated, and for example, in the community, we may say that the operator should declare the location of data centers. And also we may be able to develop technologies whereby users can verify that your data is stored in the location that you are aware of. So that kind of technology and also operation policy can be defined by the community, so that data sovereignty cannot. You don't have to be concerned about data sovereignty.
Which I'm sure is where the standards are being set by people like the IOWN Global Forum right now. Can you tell me a little bit about that and who else is in it?
Oh, great! Of course, IOWN Global Forum is founded by the three companies, NTT, Sony, and Intel. And right now we have about 170 memberships. And of course, NVIDIA, Cisco, and most of all IT and network companies are members of IOWN Global Forum.
Are there any specific industries you can see standing to gain the most from the shift towards photonic networks?
Of course, basically, cloud service providers and the data center service providers are now interested in interconnecting their data centers with photonic-based networks. I think that these are the first users of photonic-based networks.
We're coming to the end of the first episode of this interview, so thank you very much indeed for your time. But perhaps before we stop, you could just give us an idea of where people can find out more if they're interested and they can't wait for next week. Where people can find out more, is there a website? Where can people find out more about you and IOWN Global Forum?
IOWN stands for IOWN, so please search with the keyword IOWN, IOWN. And also, you may also use another keyword, APN, All Photonic Network, APN. Please do a web search using these keywords. Then you will find many articles developed by IOWN Global Forum.
Excellent. Well, for the moment, Dr. Masahisa Kawashima, thank you very much indeed for your time.
Thank you very much.
And that's it for the first part of this interview, but there will be more next week. Oh yes, come back and we'll talk about an awful lot of the barriers to making this reality. We'll look at how we are going to see this at scale and an awful lot more. See you then. Thank you very much.